Hello, everyone, and welcome to Circuit Stream's workshop. Happy Wednesday, maybe even Thursday for some of you out there. Before I do continue along, could you please let me know in the chat box to the right there, can you all hear me and see me? I just want to be sure that you can all hear me and see me before I do continue on. Jack, good seeing you again, loud and clear. Michael, Abhishek, Alex, Husnain, Kyle, Vernice, Borislav, Alan. Hey, thank you all so much for letting me know that you can hear me and see me. Good seeing you as well, Mera. Dayon in the crowd as well, one of my colleagues. Thank you all so much for joining us on another workshop here at Circuit Stream. Super excited to have you all today. Before I do continue along, there's a few housekeeping items that I would love to share with you all. So to the right, as you may see, there is a chat tab there. Feel free to toss in any questions you may have or just any comments about things, network with each other, really anything in the chat there. But if you do have any questions for us, for our team, whether it's myself, my colleague Jerry, who will be coming in doing the LiDAR portion in about 15 minutes or so, or our team backstage, please toss any questions you may have in that questions tab to the right. It allows us to really keep the questions organized, see what we haven't answered, and what to get to throughout the workshop, but also at the very end. At the very end, we have our in-depth Q&A session where we'll bring out these great questions that we have that we may have not covered throughout this workshop and webinar. Now, beside the questions tab, there is a polls tab as well. And this tab, I will be tossing in polls throughout this workshop and webinar just to gauge the experience of the audience and to ask you all some questions just to see where you are all at the moment. I do see Gabriel here had asked the question in the questions tab, will the recording be available? Yes, this is all being recorded and will be sent out to all of those who had registered. So I hope that answers your question there. But as an example, in the polls tab, I'm actually going to toss in a poll right now, just so you all get familiar with how it works. For instance, I'm going to toss in a poll to ask you all, what devices do you own, if any at all? Let me know. Go to the polls tab. Curious to know what devices you have, if it's an Android device, if it's an iOS Apple device, maybe some headsets that you're working with currently. Do you have a Quest? Do you have a HoloLens? Really interested to know what you're all currently working with, what you currently may own. And just looking at, there's a lot of iPhone users. Makes sense. We're on the LiDAR workshop here today, but a lot of different headsets floating around here, numerous Oculus Quests. So glad to see that you are all very familiar with that polls tab right there. Now, one thing I would love to ask as well, I myself am located in Calgary, Alberta, in Canada, and we have people joining us from all over the world typically. Let me know in the chat, where are you currently tuning in from? I do see Diego from South Korea here, Alan from Belgium, Gerardo from Boston, France, Texas, Austria, Germany, the UK, lots of Canadians out here, Turkey, Italy, Pakistan, some more Canadians and Americans, Miami Beach, Elias, that's it. Lots of people from all over the world again, so thank you all very much for joining us today. Again, this is all recorded, so if it is quite late for you, no worries. Feel free to have dinner, go to sleep, whatever it may be. The recording and files will be sent to you for review at any time. So feel free to kick back, relax, watch and observe the workshop webinar, ask any questions you may have. And if you want to work on things on your own time, you can use the recording and files that we send over right after this. But without further ado, let's get started here. Again, thank you all for joining our LiDAR sensors workshop here. Super excited to have you all with us. Now, one thing I'm going to do as an introduction, as we continue waiting for some people to join us, I'm going to play a quick minute and a half video for all of you who might be new to LiDAR or not know what LiDAR is. This is a fairly brief and general explanation of LiDAR, but we will go more into depth about augmented reality and LiDAR, the LiDAR on the iPhone and how to work with that on the kind of more hands-on technical portion that we cover in about 15, 20 minutes here. But I will play this video. It's about a minute and a half, and I'll be right back and continue on with this workshop here. So here it goes.
It's mainly used by scientists, usually in the form of LiDAR drones, to examine the surface of the Earth, and it's used in conjunction with other sensors on various autonomous cars to help them get a better sense of objects around them. Now, LiDAR stands for light detection and ranging, and is similar to radar, just using light instead of radio waves. Radar stands for radio detection and ranging, by the way. So how LiDAR works is that it fires out rapid pulses of infrared laser light in quick succession. Lasers being just super focused wavelengths of light, by the way. Now, that light then bounces off objects in front of it and returns to the LiDAR sensor. The time it takes for the light to make that round trip is then calculated and used to create a 3D model of the object that can be used for measuring distance to the object, height and shape of the object, etc. Now, radar, on the other hand, does the same thing, but with radio waves, as mentioned. So it sends out radio waves that then bounce off of objects, and then the time it takes for them to return is measured to determine the distance and position of the objects, etc. Now, one of the major differences between LiDAR and radar is that LiDAR is a lot more accurate and can create more defined 3D models, whereas radar, on the other hand, sort of sees objects in more of block-like shapes. Because of that fact, LiDAR can be used to more easily determine things like, say, the way a person is facing, a hand from a face, the number of branches or leaves on a tree, etc., where radar would just have a much harder time doing so.
Alrighty, so again, quick kind of introduction to you all about what LiDAR is for those of you who might not be familiar with it. But we'll continue on. We'll relate it back to augmented reality, the iPhone uses of it, and actually show you how to work with that yourselves. But again, I'm going to take about 10 minutes here to introduce you all to who we are, what we do here at Circuit Stream, and then I'll invite my colleague Jerry onto the stage to do the LiDAR deep dive, which will take about 30 to 45 minutes. Right after that, I'll rejoin, wrap this all up, offer you some resources to take this to the next level if interested, and then we'll open it up for our live and in-depth Q&A session at the very end. So it'll be about 15, 30 minutes, really depending on how much time we have here. But you can expect this workshop to last about an hour and a half. And again, this is all recorded. So feel free to sit back, relax, observe, watch, ask any questions in the questions tab or in the chat there. And we will send this all to you later on so you can work with it on your own time if we do go a little fast for you all today. But introducing myself, my name is Stefan, and I'm part of the education here at Circuit Stream. So I myself have over 7 years of experience in the tech industry, working with travel IT companies, learning management system providers, business integration platforms and ERP products, as well, and now in the world of virtual reality and augmented reality. And then a little fact about myself that I like to share, an icebreaker. I was a member of Water Polo Canada, trained with the Beijing Olympic team back in 2008. I was still a very young teenager back then, so never had the chance to go to the Olympics, but nonetheless, a great experience on my end there. And today, it's an honor and a pleasure to have our head of education and my colleague, Jerry Medeiros, joining us. He himself has over 10 years of experience in this industry, AR, VR, game design. He has a background in games technology and interaction design, a master's in computer science, and a little icebreaker about Jerry here. He himself is a certified scuba diver. So any of you scuba fanatics out there, feel free to give Jerry a shout, and I'm sure he'd be more than happy to chat about that with you all. But a little bit about us and here at Circuit Stream. Who are we? What do we do? Well, Circuit Stream was founded in 2015 when we noticed the gap in helping people learn how to create their own VR and AR experiences, whereas a lot of other people were out there trying to create content and sell them or whatever it may be. And since 2015, we've been holding these online live courses to help train people on how to use AR, VR technology. And we've had the pleasure to reach over 30,000 people with our educational programs and curriculums. Now, Circuit Stream is a Unity certified training partner, and training partners are approved based on their expertise, focus on quality education, and commitment to providing the highest level of training available. Our instructors like Jerry are Unity certified instructors, so you're all in great hands when you're learning some cool content from him there. Now, there's, I guess, two main kind of pillars of our business. And the first one, our bread and butter, has been education and training since 2015. And these are just some of the companies and professionals that we've had the pleasure join us to help them learn how to create their own content, implement it back at their companies, upskill their employees, really just to help them learn, manage, and implement VR and AR technology at their workplace or for themselves personally. From YouTube, Nike, Raytheon, Maxar Technologies, various educational institutions, Hershey's, the chocolate company. It's truly been a pleasure and honor to have these folks with us. And how do we typically do this? Well, we have two main courses. Our flagship XR Development with Unity course, what we've been holding and adapting since 2015. This is our beginner-friendly program, 10 weeks long, 4 hours per week. I'll get into it a little later on. Our next program begins April 27th for anyone interested in diving deeper into this. Now, we do also have a more advanced program, I guess you could put it, our XR Project Accelerator. For those who have created their own pieces and content, really looking to polish it up, take it to the next level, and learn some more in-depth features. And that's 8 weeks long. I want to say it's about 5 hours per week, if I'm not mistaken. And both of these come bundled with private sessions that I'll get into right here, right now. So all of our courses, these XR Development and XR Project Accelerator, come with private one-on-one sessions. And that's what really differentiates us from the other providers out there. One-on-one support and mentorship. As you're learning how all of this comes together, you get private sessions to work on your own projects and ideas. Have a portfolio piece, a prototype, proof of concept, really to continue working on, show others, or leverage one way or another. And there are various short courses that we offer here as well. From Introduction to C# for those looking to get into Unity. Unity uses C# coding for those of you who aren't too familiar with Unity. And an Introduction to XR Design for those who are maybe more focused on the design side of things rather than the programming and the development side of things. And I will touch up on that later on. And the second thing that we do here at Circuit Stream is content creation and consultation. So all of our mentors, instructors, and teachers are current VR, AR developers working with companies around North America. So everything that they're currently doing, working with these companies, they bring back into our program. So everything is up to date, relevant material, applicable to today's work. Now that you've learned a little bit about us, what are you all here today for? What are you going to learn? Well, today we'll dive into what is LiDAR and how you can apply it in mobile AR projects. We'll also go over the limitations of mobile hardware for AR, how LiDAR enhances AR applications, and setting up AR Foundation to work with LiDAR capabilities. And that's where Jerry's going to come in and really show you the nitty-gritty, the ins and outs of everything there. Now, I love asking this on all of our workshops and webinars, and I will be tossing in a poll right here. On a scale of 0 to 10, how much Unity experience do you have? So go over to the polls tab. Let me know. 0, I've never heard of Unity. 10, you're the Chuck Norris Jedi Master of Unity, potentially an instructor professional yourself there. Really helps us gauge the experience level of our audience and how we should kind of tailor this workshop as we go along. But it looks like we have quite a few 5 and under. So I would say beginner intermediate folks with some advanced ones here as well. So I'm sure you'll all learn some cool stuff about LiDAR, how to work with it, how to think about it, implement it, and so on. But for those of you who put a 0 or maybe a 1, what is Unity? Well, Unity is a free 3D development engine for building games, simulations, and experiences. It's the easiest way to begin making apps for XR. Now, XR stands for extended reality, and it's the umbrella term for augmented reality, virtual reality, and mixed reality as well. Just kind of a short term that we like to use to encompass kind of all of the things in this industry here. And how does one actually go about creating their own project or experience using Unity? Or maybe working with LiDAR on their augmented reality projects or something they will be working on later on? Well, you have an idea and you bring this idea into a creation engine like Unity. And that's when you start developing and designing your experience and projects. Once you've done that, you push it out or use an SDK to then push it out to one of the devices that you're hoping your experience to be on. So ARKit, AR Core by Google, maybe the Microsoft SDK for the HoloLens headsets. Quite an easy process. Idea into a creation engine, develop it, work with it, use an SDK, push it out to one of the devices, and voila, you've got your own published experience ready to go and show to others. But today is an introduction to LiDAR sensors. And I'm going to take this time to invite my colleague Jerry onto the stage here. Again, it's truly a pleasure and an honor to have Jerry join us. And as he's making his way onto the stage here, I'll talk a little bit more about LiDAR and relating it to augmented reality on these mobile devices. So why is LiDAR on our mobile devices such a breakthrough for augmented reality? Well, that's because previous mobile AR experiences were only as good as the device's camera allowed them to be. So typically they're limited by a single viewing angle. Features like depth were easily thrown off by bad lighting and can't always be counted on in the real world. With a sensor that can create accurate environment maps, some may ask what's on the table that wasn't before. Well, with depth on our side, developers now have access to obscenely accurate measurements that play nice in any condition. So say your project needs a pinpoint accurate map of the room you're in. Instead of detecting the room piecemeal, one wall or floor at a time, a LiDAR sensor creates a full 3D wireframe all at once, delivering both speed and accuracy. So with this, I'm going to wrap up the introduction here. I'm going to pass it off to Jerry. Jerry, thank you again for joining us on this workshop and webinar. I'm super excited to learn more about this cool tech. I've got an Android phone, but I probably will have to move to an Apple device here pretty soon.
All right. Hello, everyone. Great. Thanks, Steph, for the intro. Before we start here, I would like to check if everyone can hear me and see me well. I am in a place with not a good internet connection, so if something happens, I will try to get back as soon as possible. All right. Cool. So today we're going to be going through a little bit of LiDARs, how this thing works, what it is this just the buzz? Is it really worth it? And I will try to explain that from scratch, like from the beginning, so everyone here can learn a little bit about it. So before, I'm going to be dividing my workshop here in two parts. So first, I'm going to talk a little bit about why LiDARs are interesting for AR. So I'm going to go over how it works, what is possible to do with that, and why it was not possible to do things before. So I'm going to go over the technical details of the mobile AR here. And then after that, we're going to jump into Unity, and I will show you guys how to interact with the mesh that the LiDAR can generate. One thing that is important to notice is that everyone is going to receive the recording afterwards and the instructors to get AR Foundation working in the project, and also the code that I'm going to be generating here. So I don't expect everyone to follow along throughout the entire process. I will probably rush at some point. So if it's, just don't feel anxious about that. You're going to be receiving everything that you need in the end to reproduce the steps here. All right. The main reason for that is because I'm pretty sure that most of you guys don't have, or maybe don't have yet the iPhone 12 in there. You're not on a Mac, so maybe you won't be able to build anything. So I'm going to make sure that I explain the concepts and what is possible to do. And then in the end, you guys will receive everything that you need to reproduce that. All right, so let's get started here. I'm going to start by sharing my screen. And please let me know if you guys can see it. If it's just fine in there. Oops, I don't think I am in the beginning of this. Now I am. All right, can you see it? Perfect. Amazing. All right, great. So let's get started. If you're a completely beginner and you have never played with this word before and you're curious to know what it is, I'm going to start by defining here what augmented reality is. So Steph had gave a pretty good introduction on that. But when we talk about AR, we're basically telling that, or we're basically working with something that uses part of the real world into a digital world. So basically, we're merging those two things together. The main portion of our application is going to be something that I capture from the real world. So basically, what I'm doing when I develop AR is superimposing uh, virtual objects, 3D objects, 2D image, video, something into the world. So basically, I'm gonna make people believe that something exists in my environment, even though it doesn't exist in there. So there are lots of applications for that. So people have been using that for training, education. So if I want, for example, to teach someone how to fix a machine or how to operate a machine, we can just add some callouts in there, add some pop-ups, some things that doesn't exist in that place, and they are gonna show the step by step. If you want, for example, to decorate your house, like to buy some furniture, piece of furniture, and you don't know if they're gonna fit, if they're gonna look good in your environment, so you can just use an AR application to place those pieces of furniture in there. So basically, we use that in different situations. They can be used for games, as we have been seeing people playing the Pokemon Go, for example. So it's basically like we can place a virtual object on like a Pikachu or some other Pokemon in the environment. So basically, that's what AR is about. We have, regarding hardware, we have basically two ways of delivering AR applications. One is using a headset, such as the HoloLens or the Magic Leap, and the other one is the handheld. So we're going to be using like a mobile device, such as Android or iOS. There are some differences between them. Like the headsets, they are designed and developed for AR. So they are usually a little bit more powerful. They have more sensors, they have more quality. That's basically what they do. While the handhelds, they are basically more generic. So they are not that powerful in terms of what they can deliver for AR. This is changing. That's why we are here today. Like the iPhone 12 Pro and the iPad Pro with the new sensors, they are adding a new layer in there. But in general, handhelds, they're going to be less powerful. There are a couple of different ways that we can make AR work, from the simplest to more complex. So one of the ways we do that is basically detecting image markers on my environment and placing the 3D objects or the virtual objects on top of those markers. So basically, this is the simplest thing that we can do. We can also have location based. So I know that I am in this specific square. So I'm going to place something there based on the GPS location. Or we can have completely markless AR. So we don't use like a predefined image or a predefined location. We're going to be using features of the world, things that we can detect in that world. We're going to see what are the options in a while. So considering the types of devices, headsets and handhelds, and the types of applications, marker, location, or markless, we can classify AR in two different categories. So the first one is what we call weak AR. So it's still augmented reality, but it's simpler. The mapping is not that precise. My application doesn't know the world. It just knows a couple of features, like the image marker, for example. And then the interaction with the world is a little bit more limited. Like it's not super realistic. Actually, most of our handheld device, they are going to provide weak AR for us. And it's changing now. But in general, usually the weak ARs, the weak AR applications, they are handheld based. On the other side, we have what we can call strong AR. So those, they have full awareness of the environment. So they know how the world looks like. It's just not a couple of features, but the entire world. And then they are more precise and accurate. So we can do more complex things with those types of AR applications. Hence, then the interactions are more natural. We can have our 3D objects, our virtual objects, interacting with the world in a more natural way. And usually they are handheld. They are head-mounted displays. So the headsets, usually they are more on the strong AR side. But that's changing. with, as I said a couple of times, like with the iPhone 12 and the LiDAR sensor, it's changing a little bit. All right, so in terms of what we usually have up to this point, how most of our applications in AR work. So the majority of them are basically marker tracking. So we have an image, it's predefined, we find what it is, and we place an object in there. We update the position and the rotation of the object. This is cool. It works super fine. We can make that in any mobile devices out there. So there are advantages, but we cannot like place post-its or QR codes or images everywhere in the world. So it just makes our application a little bit more limited. So in between what we can do with strong AR and this thing that is the simplest one possible, we have what we call plane detections. So basically what people have been doing lately is working with planes. So we can find in the environment vertical planes and horizontal planes, map them, and position our objects related to those planes. This is nice. This is really cool. Like it makes the application a little bit more accurate and a little bit more interesting, but it's not super precise because I still don't know the environment. I just know some planes that were detected in there. And if you have like a super powerful device, maybe you're gonna have better planes. But if you have a simple device with like a camera that is not that good, maybe the planes are not gonna be that accurate. One example, I have like one Android phone at my house. It's not like super new, and it never detects the planes, my walls, for example, because they are all white. There is no contrast, so I can only work with that phone using horizontal planes, like the floor, but never the walls. So there are some limitations in here. How this thing works up to now. So basically, the technique that the devices were using before the iPhone 12 is called visual inertial odometry. So this is basically combining two types of sensors. One is the sensors that give me the position and the rotation of my device in the space, such as the accelerometer, the gyroscope, and the compass, for example, so I can know if my device is moving or rotation. And we combine that with the image that my device sees. So it's all about image processing. It's computer vision. I have the camera feed. I look into that image. I try to classify and to process the pixels and tell, well, it seems like there is a plane here. So this is how it works. It's good, but it's not super accurate because actually I don't have information about the world. I don't know what the surfaces are there. I just know an image and I try to process that image in the best way that I can. More modern devices, they're gonna come with depth cameras. So we have a little bit more of information. I can see, for example, if one plane is closer or farther from the camera, but actually it is still only about image processing. I don't have information about the world. All right, so how does a LiDAR fits in this context? What this thing is? First thing that I would like to clarify, that LiDAR, just this name or this acronym, LiDAR, this is not a hardware thing. This is just a technique. So a LiDAR sensor is actually the hardware, but people just usually say, well, the iPhone 12, it comes with a LiDAR. Actually, it comes with a LiDAR sensor. LiDAR is just a technique. But what this technique is in the video that Steph showed, they clarified that in a very good way. But basically, it's just a technique. It means light detection and ranging. I almost forget what it means. But basically, it's just a method that measures distance from objects using a laser. So I just send a laser and see how long it takes to return. Then I can see if something is far from me or close to me. We're gonna see in a while in more detail. But what is the good thing about the LiDAR? Given that I can actually recognize if there are objects in my world and where they are, I can send lots of lasers, lots of lights in there, and reconstruct my entire environment. I can see if the light is bouncing from this, there is an object here, how long it takes. So I can send multiple lasers. They act like pixels, like small portions of the world, and we can just reconstruct the entire scene. So what it gives now to the iPhones, and maybe in the future to other phones as well, is the possibility to build strong AR applications, because I have a knowledge of the entire world. I can place objects there with more precision, and then I can make more interesting applications. Another thing that the LiDAR is gonna allow us to do is basically scan objects. So that's a second application. We can, for example, well, I have here a furniture, and I want to get there inside of my application, but I don't want to model that. So I can just scan that with the LiDAR. I'm gonna have the mesh of that specific piece of furniture, and then I can apply a texture to that, and then I have a finalized 3D model. So that's basically what the LiDAR gives to us here. How this thing works. So just in a more technical thing, it's very, very simple physics. So we have like one laser, not only one, it's lots of them, but let's see with one. So we just send this light, and we wait for this to bounce and come back. And then, oops, and then I can just measure the distance here, because we know the formula of the distance is basically multiplying the velocity by the time that it takes to come back. And in this case here, we just need to divide that by 2, because it takes some time to go and the same time to come back. So here C is the speed of light, because we are playing with light. So this is known. We always know the speed of light. We multiply that by the time that it takes to come back, and then we divide that by 2. So here I know the distance from my camera to anything that was hit here by this light. And then this is basically how it works. So here we have this LiDAR. It's moving in circles, and then we can see that the light comes here, it bounces back, then I know the distance. I can reconstruct where this object was. So basically that's the final result here. I can have multiple points, know where they are, and then I can reconstruct a mesh from those points. All right, so before I continue here, let me see the chat real quick if there's something interesting. Drop me a message. Jacob, anyone know the difference between a LiDAR and a radar? Oh, they are basically the same thing. The difference is what they use. So the LiDAR uses light and the radar uses sound. Yeah, so that's basically it. The sound, we know the speed of sound as well. So the sound is like 3,600 and something. So we just multiply that by the time. The thing is, it's a lot, it's more expensive to make ultrasound than making lasers in a spectrum that we cannot see. So it's basically the same principle, but the LiDAR is gonna be using light, and the sonar or the radar is gonna be using sound. All right, perfect. So now let me show you guys some applications here that are possible to do. Let me stop sharing this for a quick while and share my entire screen. So I hope you guys are seeing it. I would like to show here my device. So I'm just basically mirroring my iPhone here. I'm gonna show you guys 2 applications. I didn't develop them. They're not getting anything to advertise for them. It's just because they are interesting. So the first one is this LiDAR camera. This is gonna show exactly what my LiDAR is seeing. So we can see here, for example, that it's able to it's basically able to reconstruct where I am. And we can see that it's not only in terms of planes, but I can get everything. So basically, this is what it does, and we call that process meshing.
Gotta be internet. Gotta be internet. I thought it was maybe only my internet here, but we'll wait for Jerry to maybe fix this up a little bit if he can still hear us or not. But Husnain's asking, what's the app name? I missed that one, so we'll have to send it out when Jerry comes back here. Dayon, if you're there, Backstage, do give Jerry a shout there. Borislav, time to order food. Hey, great time to do it. And Tom, app name I think is Lidar camera. Could very well be that. Jerry did lose connection here. So let's see if there are any questions that I can get to as Jerry figures out his stuff here. Christopher is asking, is Lidar the same as a time of light depth sensor? I want to say it will be, but I don't want to give you the wrong information there. And we've got Michael, Lidar camera was the name. Perfect. Nathan Miller, go to the questions. Let's check it out. We'll have to leave some of the more technical ones to Jerry here. But let's see if we've got anything that I might be able to shed more light on. Okay. Just scanning through. Let's see. Daryl, how effective is the iPhone 12 Pro in scanning space objects for 3D use in Unity? What would be the next available options of current LiDAR devices to consider to increase quality? So as far as I know, it's these iOS devices like the iPhone 12 Pro. I'm sure Jerry knows some other ones that he'll be able to speak to a little bit more. And let's see if there's anything else that I, the newbie here, might be able to shed more light on. Boop, boop, boop. I'll hop open to the questions here. Let's see the chat. It uses time of light to estimate the beam hit from laser back to camera. Yeah, that's a good one, Steven. Jerry just pinged me now, trying to reconnect. Thank you, Kyle. Kyle's also part of the education team here at Circuit Stream, so feel free to give him a shout if you have any questions as well. Is the LiDAR camera app native in iOS? That's a great question. I don't have an iOS device, so I can't really speak to that. Anyone here with an iOS device? Jack is saying nope, so I want to say that's the answer. Stephen, pleasure to meet you as well. Is it Stephen or Stefan? Not too sure there. Kyle's
back. Hello, am I back?
Hey, yeah, you can see it, Jerry. Welcome back.
All right, great. Where did it stop? I was just talking to myself here. I didn't notice that the internet dropped. So.
Yeah, if you pop open your slides, I'm definitely able to show you where we had stopped.
Okay.
So Kyle just says it's right when you opened up your LiDAR app, when you were about to do the phone stuff there.
Okay, I was just demonstrating to myself. All right, let me get back to it. I'm sorry, I don't know what happened here. I just got disconnected, but it seems like I'm back. Okay. So what I was trying to demonstrate here is like two different applications. And I saw someone asking in the chat if this is native to the iPhone. It's not. So I got those apps in the App Store. They are free to some extent, but you can test them for free for sure. So the first one I was trying to see here is this one, which is, no, not this one. This one, which is the LiDAR camera. So basically what it does is just show me exactly what my LiDAR is seeing. So we can see here the mesh that is being reconstructed. You can change like the visualizations, but it's not really important. So basically what we see here is exactly what my LiDAR sensor is able to see. So that was the first thing I demonstrated here real quick. The second one is this other application, which basically is going to allow us to transform something that my LiDAR is seeing, such as this mouse here, into a 3D model. So you need to be patient, because it's trying to isolate only the mouse. So if you have more patience that I have in here, at some point, you're going to have a cool representation of this thing. So here it's very, very broken just because I wasn't scanning that for long enough. I think I have here better representations as this one that I did a couple of days before. So this is a 3D model that you can export and use that in Unity or in any other software that you want. So basically, those are the two things that we can do with the LiDAR. The first one is reconstruct the mesh so we can interact with it. And the second one is basically reconstructing objects and exporting them as 3D objects. The third one is the thing that we're going to try to build real quick today in Unity. I made that so we can see some examples. But basically here, now it's Unity, it's my Unity application, and I can just place like a couple of spheres here, and we can see how they interact with the real world here. So basically, they are a little bit bouncy. They can grab it or fall in there. Well, if I click here where the mesh doesn't exist, they're gonna fall. But that's just because we need to make some treatment. But basically, that's what I would like to show here. It's possible to interact with the mesh in a very realistic way. All right. Cool. Let me stop sharing this real quick. Is it fine? Is it working just there? Does the light the hardware using for not actually see? All right, cool. So now let's continue. I will share here real quick again. Oh, Sarah, how did you get your Unity project into that? You need to build it. You need to have a Mac in there. Well, I can, in the end, I can quickly show more or less how to build, but we can send later instructors for that. So you need to have a Mac and Xcode installed. So you need to build your Xcode project. There are
Another one, and another one. So, boys backstage, do let Jerry know we've got another choppy one here, but we'll be sure to get him back there. But hey, thanks all for hanging on in the chat there. Jerry, yeah, Jerry isn't at home currently. I think he's remotely somewhere else, so the internet's probably not as gold as it should be there. So apologies for that, but lots of great chats here. You guys supporting each other, so really appreciate it. Tom, thanks for the feedback there. Hopefully we'll get him back here up and running here shortly. But let's see, do consumer LiDAR scanner sensors exist outside of iPhone 12? So I think there are other definitely devices out there. However, for mobile devices specifically, I do want to say it's just for the iPhone 12 at the moment, iPad as well. But do correct me if I'm wrong there in the chat. But lots of great stories here. Also curious to know, I'm going to toss in a poll here as we wait for Jerry to join us again. But curious to know, what industry are you interested in potentially applying LiDAR to, or maybe working with AR, VR technology with? I'm going to publish the poll just to see what industries you all might be working in or interested in applying this to. So we'll see what the results here are. Currently, we've got some aviation, film, medical, and healthcare. That's a big one, medical and healthcare, that I've actually heard of a lot of recently, and education as well. We've got a lot of others, some training and architecture. For those of you who said other, what's the other kind of industry or category that you guys are looking at? I see Jack Harrison here, music, Jason Jaslow with e-commerce. Jason, good seeing you, my man. Good seeing you. Michael Reno, only one to choose. Very true, very true. Kyle, great seeing you. Theater, public safety, travel and tourism, theater, 3D printing, manufacturing, geography, cave mapping. That's a very interesting one. Very interesting. We've got Stefan again here, fusion engineering. Very cool stuff. Kim doing theater, dance, and music. Michael, mobile scanning. And I want to use it for art and theater. So there is a lot of different ways that you can really apply this stuff to. Daniel saying GIS, laser scanner is hard to drag around. This is true. This is very true. But let me pop open to the questions tab here, see if there's anything that I can still shed more light on. A lot of quite technical questions, better tailored for Jerry. So nothing that I am confident in answering there. But let's see. We've got Jerry back. Welcome back, Jerry. We're just going through different industries people are hoping to use this for. Susanna Ruiz, games, narratives, and theater. Wonderful. Very cool. But Jerry's back. You know,
Yep.
I'll hop off here again, and I'll be sure to pop back in should anything else happen.
Hello. Yeah, I'm sorry for that. It's just that the internet is super unstable here. So just if someone can say, tell me where did it stop? What was the last thing that you guys got from me? Someone? Well, all right. I would just assume that it stopped right here. You were discussing mesh. Demo interaction reward. We were discussing how to get Unity project to the app. Ah, okay. Yeah. So okay. So the other thing that was I would like to share here is I gave a spoiler already. If it's possible to get that in Unity or not, and we already know that yes, we can. So basically, what we need to understand here is how Unity works with XR. So basically, we have a couple of components that work together, and they are called the thing that we as developers are going to be using in order to develop. So we have AR Foundation here, for example, and today we're going to be using that. AR Foundation is an abstraction that just allows us to write our application only once, and then we can deploy it to multiple devices out there. And the way it works is basically we have the subsystems. They're going to give us access to different features, such as the meshing, as we're going to be seeing today, plane tracking, and so on and so forth. So AR Foundation requests access to those subsystems, and they request access to the hardware by using the native implementation. So for iOS, for example, we need ARKit. For Android, we need ARCore, and so on and so forth. So this is the stack out there. We can see here that not everything is available for all platforms. So until a couple of months ago, we didn't have meshing available for ARKit. But now with the iPhone, we do have that. So we can see that Magic Leap and HoloLens, they also support meshing, but the AR Core doesn't, because up to now, well, we don't have any AR devices for Android that can actually make AR Core, that can make mesh work. But maybe in the future, this is gonna be updated. So that's it here. Let's get into Unity and see what we can do there, how we can actually have Unity working with the LiDAR sensor, how we can get that thing. I'm gonna be sharing my entire screen here real quick. And open Unity. All right, so this is Unity here. If you have never seen Unity before, what is the thing that we need to know here or to add here? Well, we need to prepare our application for AR. We need to import one thing here, which is AR Foundation. So every time that we import something into Unity, we're going to be using the package manager, and we just search for the package that we want. The one that we need is AR Foundation. Don't worry, I'm going to be sending you instructions on how to get this project set up, so you guys can do that in your own pace in there. Just focus here on what is necessary and what are the concepts. So AR Foundation, as I mentioned, is the abstraction that is going to allow us to deploy to every single platforms out there. Given that this project is for iOS only, we will need to import the ARKit plugin as well. So ARKit is basically the native implementation for iOS devices. So we need to have those two things, AR Foundation and ARKit. So those are the things that we need. Now that I have those imported, given that this thing is going to be an AR application, we need to add a couple of components here, a couple of game objects here to my scene. The first one is going to be the AR session, the AR session object. So what the AR session is, it's basically the core of our AR application. It's going to track everything that happens in the world and map that to my scene into Unity. So we need to have that. Every time that we create an application that is AR, or using AR Foundation, we need to have the AR session. The other component is the AR session origin. So this is basically the object that is going to translate the position of my device. So if I move or rotate my device around, it's going to translate that into the position and the rotation of my AR camera here. The AR camera is already a child of the AR session origin. This is because every time this thing moves as well. So it's going to be tracking the position of the device and replicating that into the position of the camera. All right, so those are the things that are mandatory here. We want to work with meshing, right? So I want to access what are the meshes that my device is detecting using the LiDAR sensor and do some interaction with that mesh, right? So in order to do that, I will need to create an empty game object here as a child of my AR session. We can name that anything. I'll just name that mesh manager, for example. And then what I need to add to this thing is basically one component called mesh AR mesh manager. Oh, it needs to be a child of the AR session origin. I'm sorry. Instead of AR session, it needs to be a child of the AR session origin because it needs to reposition the mesh as well. So here I need to have an AR mesh manager. What this AR mesh manager does, basically, it's gonna communicate with the AR subsystem that is gonna communicate with ARKit, request all the meshes, and then bring the information from the meshes into Unity. So that's what this application does. It's gonna give us information about the color of the mesh, the normals, the tangents, everything on that mesh, and then we can interact with that. If you want to draw the mesh as we were drawing here in my application, for example, just making that blue, we need to create one prefab that's going to represent that mesh here. So we just need to have any prefab that is a mesh filter with a mesh render here. So let's see what is the easiest way to do that and represent that mesh. The way I usually do that is I create here any object that has a mesh, for example, a cube, a sphere, anything. So let me create a cube, for example. And then we need to remove a couple of the components here by default. For example, I don't want to have a box collider in this mesh. So I can just remove that. If you want to interact with the mesh in a realistic way, like I want my objects to bounce in that mesh, to walk on top of that mesh, we can replace that with a mesh collider. So mesh collider is basically the component that is gonna detect collisions between anything in the world and this specific mesh that was generated. We do need to have a mesh render because the mesh render is the component that is gonna draw the mesh for me. But we don't need to have this cube here as the mesh filter. So I can just make that known in here as well. Why is that? This is because the mesh filter is basically the component here that draws a cube, right? But in the end, what I want to draw is the mesh that was detected. So Unity, using the AR Foundation Mesh Manager, is gonna create that mesh for me. So we don't need to worry about what is the shape of the mesh here. And then that's it. Now that I have this thing with the mesh filter without a mesh drawing here, a mesh render that is gonna draw it, and a mesh collider, that's basically enough to make my mesh be rendered. One thing that we can do is basically change the color of this mesh. So if I create here, for example, a material, and change the color of this thing. For example, here it's going to be, I don't know, blue, maybe. We can just select this cube and drag this material here. So now every time that this thing draws a mesh for me, this mesh is going to be painted in blue instead of in the default gray here that comes with a regular primitive. All right, so now I can just make that into a prefab. Delete this because it's going to be instantiated by the mesh manager. And here I drag the mesh prefab just here. So now I didn't write any single line of code, and I already have this application detecting the mesh using the LiDAR sensor if it's available, and drawing a blue mesh on top of that. So I didn't write any code, and I already have this working. So AR Foundation makes that a lot easier for us. So now let's see how we can have actually access to this mesh. I will create a very, very simple script here that access the mesh that is being generated. So I'm just gonna call this script mesh. Open that script and show you guys how to have access to the mesh. So you can change like the color of them, you can raycast against them and do whatever you want. So the information about the mesh, it is into the mesh manager component, right? So everything that we need is gonna be here in the mesh manager component, AR mesh manager. So I just need to have access to an object of that type. So I will create here an AR mesh manager. In order to recognize that, we need to import the AR foundation. So I just click here to import Unity XR AR foundation. So now my application knows this. If I make this public, for example, oops. If I make this public, for example, I can go back to my inspector, and we need to assign our script to anything here. So let me drag my script here. This is the script that I have just created. Now it requests a reference to the mesh manager. So I can just grab the mesh manager and drag it here. Now inside of my script, I have access to it. And now let's see how we can actually access the meshes in there. So public void start. So the start function is a mono behavior function in Unity that is called only once. It's called in the beginning of my application. And then if I try to access here my manage, it's gonna have one option which is called meshes. So this meshes is basically a list of all meshes that were created. And this thing is updated every time. So in every frame, this thing is updated. So if I want, for example, to loop through this mesh and do whatever I want to do here, I can just create a loop for each var, var mesh in manager.mesh. Now I have access to the individual mesh that exists in there. I can change the colors, I can change their position, I can do whatever I want here. So here's just basically an easy way of interacting with that mesh. And then we can, for example, position, like I can position something in the normal of that mesh, and I can do whatever we want to do here. In the application that I showed you guys, that I would like to show real quick how to develop. What I am doing here is basically, well, we will need to remesh here, but basically what it's doing is creating a sphere in the positions where I click in the mesh. So let's see real quick how we could potentially do this thing. First thing is, I need to detect where I am clicking in the screen, right? So we need to know the position I am clicking in the screen. So let's see how we can do that real quick in the update. The update function is another mono behavior function. It's just called every frame. So if my application is running at 30 frames per second, this is gonna run 30 times in a second. So basically, this is where I process everything that should be happening in my game. This is the game loop. So what I want to do here, first is get if we are clicking something, if I am like tapping in the screen. So we can use the input class dot touch count. So the touch count is going to tell me how many fingers there are on the screen. So we can just check, for example, if the touch count is greater than 0, it just means that at least one finger is on the screen. So I'm basically touching the screen somewhere. I need to get where I am touching this screen. So we can just create a touch object here equals to my input dot get touch. How does the get touch works? I know that I have at least one here, right? So say, for example, I have like 5 fingers on the screen. the get touch, if I say, for example, get touching 0, it's gonna give me the first finger that was touching the screen. If I say, for example, get me the touch 4, it's gonna be the third finger on the screen. This is because it goes 0, 1, 2, 4. Actually, it's gonna give me the fifth finger because it's 0, 1, 2, and 4. So they go from 0 to 4. And it's up to 10. Like, we can have 10 fingers on the screen because we have 10 fingers. But right now, I only care about 1. Like, if I'm pressing with the first finger, I just want to know where this finger is on the screen. Now, what I'm interested in here is basically where is the position of this finger, right? So my touch here is gonna have a position. This position is basically in pixels, so it's gonna give me X and Y where my finger is. What I wanna do here is something like that. Let me open here my MS Paint. Very powerful tool for drawing things. So say, for example, we have the environment and it looks like this. So here is the environment. I am here holding my device. As you guys can see, I cannot draw, but I have my device here. And then there is the mesh. So the mesh is being recognized here. I want to place a sphere in this point, right? When I click. So basically what we do is we detect where the finger is on the screen. Then we draw a line that we call a ray and see where this ray is gonna touch the mesh. So we just place that thing in this mesh here. Given that our mesh already have a collider, because we did add that to the prefab, so we have the mesh collider, when the ray hits this mesh, we can just place an object in there. So how can we do that? In Unity, we have one function that is the ray cast. The ray cast is gonna cast a ray from one place in a specific direction, and then we can see if this ray is hitting something. One thing that we can do before we call this function is actually pre-creating this ray. So I'm just gonna create here a ray equals to camera.main.screen point to ray. So this this function is very useful when we're making mobile devices applications, because I just need to give it a position in 2D, and it's gonna give me a ray, and this ray is already moving forward from the direction of the camera. So if my camera moves, and in our case it does move, it's not a problem, because basically this is just going to ray cast from the camera. So now that I have this ray, I can just use the physics.raycast. So the physics.raycast is gonna request a couple of properties and a couple of components here. The first one is going to be the ray that we have just created. The second one, the second one is basically one object that is gonna give me the information about where this ray is hitting, if it's hitting something. So we just create here out var hit. What is this in C#? So this is a little bit confusing, I know, in C#. The raycast physics, in the physics, it's a weird function, like it works in a weird way. But basically, what this out and this var means in C# in this case. So alt is basically, I'm giving permission to the raycast function to modify this variable. So I'm just creating this var hit. I'm just creating this function here, or this variable here. And I'm telling raycast, please fill that variable with the information of the hit if the hit is happening. If it's not happening, it's gonna be null. And then the third parameter that we need to pass here, the third thing, is basically how far I want this ray to go. So it's just like a number in meters that tells me how far I want my ray to go. Well, I don't want to define that, so I'm gonna be using here the float dot max value, or dot positive infinite maybe. So positive infinite is basically the highest number that I can represent in a float. It's a very, very big number. So I'm just saying, well, it represents the infinite in computing here. So it's basically like the biggest number that we can have. This function is going to return either true or false. So true if I'm hitting something, false if I'm not hitting anything. So I can just use an if here in between this thing. And then basically what is happening here is, well, if this gets to this phase, it means that I am hitting the mesh. I'm hitting something. And then I can just instantiate anything. I can just create our ball here. So the last step is basically creating the ball. In order to do that, we need to have a reference to the ball here because we don't. So I will create a public game object ball, for example. And then here we can just use the instantiate. So the instantiate is a function in Unity that's going to create an object for me based on a template. So my template here is the ball. We need to give it a reference in a while. The second thing is, where do I want to instantiate it? Well, I want to instantiate it where the hit happened. So in the hit point. The hit point is basically the position where this ray is intersecting our mesh. And the second thing is the rotation. So I can just use the rotation of the hit as well. Or maybe we don't need it. We can just use the quaternion.identity here. So what the quaternion.identity means? Well, I don't want any special rotation, just the rotation that comes with the ball. And now this is like the basic or the most simple interaction that we can do with this ball, with this mesh. We basically detect, well, I press somewhere on the screen. I cast a ray and I see if it intersects the mesh. If it does, I just instantiate a ball in that place. So now the last thing that we would need here to have is basically one reference to this ball. So we can just create here any sphere. One thing that is important here is the scale. So we need to remember that we are dealing with AR. So this is sphere here. It's 1 meter by 1 meter by 1 meter. So it just have like 1 meter diameter. And that's pretty huge for this room. So probably I want it to be a little bit smaller, like 10 centimeters now, maybe even smaller. But basically, we need to deal with scale when we are making AR applications. And then if I want this ball to bounce and to roll, we just need to add a rigid body to that. So now it's a physics object. It's going to have a mass. It's going to collide with things. It's going to have forces and inertia and everything. And I'll just rename this to ball. Oops. Transform that into, transform that into a prefab. Select the script that I have just created here and drag the ball. So that should be everything that we need here to account for that simple application, which is detecting the mesh, drawing the mesh, and instantiating spheres on top of the mesh. And with this basis, with this preview here, you guys can start to increase or start to expand that from for more complex and more interesting interactions. But you have the basis here. So I will make sure to share resources on how to get AR Foundation working on our project. And also, you're going to receive the final code here, as well, with everything that exists in here. So even the turn on and off the mesh. So basically what this thing does, I can show real quick here, is looping through all of the meshes and then changing it to the opacity to 0 or to 0.5 when we click the button. So it's basically what I demonstrated in there. We can loop through all of the meshes and do whatever we want with this mesh. In this case here, turning it on and off. But I think that should be it up to here. So I will invite staff back to wrap up. And then I will come back in a couple of minutes to answer all of the questions you might have in there.
Awesome. Hey, thanks so much, Jerry. And thank you all for sticking around. Our apologies for the internet issues there. My Ethernet's not connecting today for some reason, so really hoping my Wi-Fi works here. But let me share my screen here. And before I do wrap things up, I'm going to take about 5 minutes to wrap things up, and then I'll invite Jerry back onto the stage here. I'd love to know what you all thought about this workshop outside of the internet connection issues, and my apologies again for that. But do let me know, on a scale of 0 to 10, how likely are you to recommend this workshop? And I'm going to toss in a poll here. It really helps us understand, should we continue hosting these workshops or not? Maybe some more LiDAR ones or other workshops around augmented reality. Do let me know. I just tossed the poll into the polls tab. So let me know. It really does help us out gauge what kind of things we should put on there. But with that, I do want to quickly shout out, we are holding an XR happy hours this Friday with our very own Nikisa Donnelly. And this is just a very great opportunity for any of you to join in live on YouTube to ask questions about the industry, AR, VR, any devices, anything that our instructor and developer Nikisa can help answer for you. So feel free to join us for our happy hours this Friday. My colleague Dan will toss in a link for all of you to check it out. But would love to have you all there as well. Now, we did fly through this content quite quickly. And for those of you who did mark yourselves as a 0, 1, or a 2 in Unity and looking to take this further, we have our XR development with Unity course, our beginner intermediate friendly program. 10 weeks long, 4 hours per week. 3 of those hours are in class, and each student gets a weekly private session, one-on-one, 1 hour on top of the 3 hours in class to work on your own personal projects and ideas to have something to show for by the end of the program. Now, the next course starts on April 27th. The full price of this is $39.50, but this is a bundle that includes our 10-week XR development with Unity course, our 3-week C# scripting fundamentals program for those of you who might not be too confident in C#, and it comes with an Oculus Quest 2 headset. And if you're looking to add an additional short course to that, the XR design course, this is also added to our Starter Pack Plus option. And if you're looking to really supplement what you're currently working on and doing in these courses, we'd love to have you with us. And again, for this course, no experience required, so beginners, have no fear. We welcome everyone from all walks of life. Now, for those of you who are familiar with Unity, have created your own projects and experiences, looking to polish something you're working on, create something new, and learn some more in-depth and advanced topics, we have our XR Project Accelerator program. This is 8 weeks long, 5 hours per week, 3 hours in class with 2 private sessions each week to really accelerate your ideas and projects with the support of our team. And typically this is held every 2.5 months. We have one starting next week, so the next one is scheduled leading into the summer. The cost of this one's $44.50, and it wouldn't be fair if we didn't have a bundle for this one as well. So it does come with a C# short course, an Oculus Quest 2 headset, and we've got the Plus Pack for anyone looking to capture more of the design side of things. Now, we do offer payment plans and financing options for those of you who are interested in learning more about this. And we have 3-month payment plans, 6-month payment plans, and you can split it up over the year, each month, 12-month payment plans. Now, if you're interested in learning more about it, feel free to download a syllabus or apply now at circuitstream.com/learning. Now, we do also offer private team training opportunities. We've had the pleasure to have the US Navy, BMW, and a lot of other groups and members with us. So if any of you do have a team who want to get going on this, feel free to reach out to myself, to my colleague Kyle, who you may have seen in the chat, and we'd be happy to explore this further with you. Again, Kyle and I are here to support any questions you may have, so feel free to reach out to any of us, and we'd love to chat about what your interests are, if it's a good fit, and how we can help. But I will invite Jerry back onto the stage here. We've got a lot of questions in the questions tab to answer. Really looking forward to Jerry answering those questions. I myself do need another 9 years of experience to get onto Jerry's level here. So Jerry, thanks again for joining us. Really appreciate it.
Hello, I'm back. Hope this thing works now.
Yeah, fingers crossed, fingers crossed. But I'm going to go through the most upvoted questions first, and then we'll make our way down. So I have one here from Tom, and Tom's asking, how do you see the benefits of LiDAR mobile AR being employed best to solve commercial problems relating to retail in the near future?
That's a really good question. I'm not an expert in retail, so I don't really. Let me see. How do you see the benefits LiDAR mobile are being employed best to solve commercial problem? Okay. One thing that I can think about is like I worked in the past in an application where people could try like clothes on themselves without being on the store. And you need to actually match the clothes in the body and everything. And that's a little bit complex if you don't have like proper mapping. So the thing I think that the LiDAR is going to be adding to mobile AR is precision. So in this case, for example, you could like detect exactly where the head is and place a hat in there or I don't know, like a scarf or something like that, exactly in that specific portion of the body, and people can try that out. So that's what I can think about. Like as I said, I'm not an expert in retail, but I think that it's gonna be adding more precision to things. So I can come up with other ideas, but I don't know. Maybe if you are like an expert in that, knowing that what it adds is basically precision, you can try to think about like better applications of that. That's the one I can think about.
Awesome. Thanks, Jerry. Then we've got one here from Joey. Joey's a professional iOS developer and would like to get into AR development. So if he's not interested in other devices, but more so interested in what's to come from Apple, would it be better to stick to ARKit, SpriteKit instead of Unity?
Yes, I would say yes. The thing is, if you are not interested in multi-platform and you are already a professional iOS developer, ARKit is just there. So there are lots of features and everything. You can just basically go there and build what you need. The thing with AR Foundation is we need to wait for AR Foundation to implement the new things in ARKit, and not all of them are there. So I know, for example, that in the iOS environment, you have like lots of things for computer vision, image recognition, and they're quite like accurate and nice. You can just train a model and recognize something super, super quick. But yeah, in your case, I would say yes, that's a better approach. The reason why most people go to AR Foundation and Unity is because it's multi-platform. So we want to build things that work in multiple devices. That's the first one. The second one is, well, people are a little bit scared with Swift and Objective-C, so maybe they just use Unity to avoid that. But yeah, Unity is gonna bring lots of interesting features to the stack. So if, for example, you wanna have like complex animations and all of those things, maybe Unity is better. But if ARKit is enough for what you're doing and you are like already an iOS developer, and you don't plan to use anything that Unity offers in terms of like a game engine, yeah, I think that it's just fine to stick to ARKit.
Perfect. Awesome. Thanks, Jerry. Hope that helps answer your question there, Joey. And then we have one from Manuel. And Manuel was asking, as someone with zero Unity experience and some LiDAR experience on iPhone, will I be able to play with my renderers and make some cool experiences in AR with them by the end of this course?
Well, yeah, finally, like I tried to go to the basics, to the concepts, what exists in there, and how to bring those things together. If you rewatch the recording and try to reproduce that, and if you get the project and try to explore that and see how it goes, I think that is you will finally be able to add like your own render, your own modules, maybe make them walk on the mesh and something like that. So yes, this is a starting point. I just try to cover like the basics, the concepts, the foundations, and then you can go from there.
Perfect. Awesome. Hope that helps as well, Manuel. And then we have one from Leon. Leon's asking, is it possible to get point cloud data using AR Foundation with LiDAR sensor? To be precise, every position of the point cloud.
No. So at this point, well, that's a good question, because you know what, in AR Foundation we have one component which is the AR Point Cloud Manager, and it works even though without you don't have the LiDAR. I didn't test that with the LiDAR, so maybe I would say that with the AR Point Cloud, maybe it's gonna get there, but I will need to test because the documentation is not clear. So I don't know. I would say no. I think that it just brings the mesh, but maybe you can explore the Point Cloud Manager and see if with a LiDAR it brings all of the points in there. So there's a chance, but I wouldn't say it's possible because I didn't test that yet. But that's a good question. We need to experiment with that.
Yeah, well, we'll be sure to note that down for sure. And then one from Kyle here. Kyle's asking, will LiDAR cameras work with 360 video, positioning live motion capture inside the panoramic sphere?
That's a possibility. That's not what it was built for. So actually, it was built to get the mesh and the 3D model of the environment, not to have like a video. But I think that's possible. Probably not trivial, not easy, but I don't see that as an impossible thing to do. I don't think that's the main application of a LiDAR. So I don't see like Apple or Unity working on that actively. So you need to develop something. But I think that makes sense.
Perfect.
That makes sense to try it and to see how it goes. But that's not the main purpose of the LiDAR. So I don't think it's going to be easy, but I don't think it's impossible.
Mm-hmm. Perfect. Then we've got one here from Nathan. Nathan's asking, how detailed can LiDAR mesh get? Is it app specific? Can it get better with higher exposure? For example, can I scan the inside of a car and then cut and program animations out of the mesh as detailed as turning a knob or pushing a button?
Yeah, so it's as detailed as the app can get it. So if higher exposure finally gets you more detail in the mesh, that's for sure. Because if you just like bypass as I did it here, as I made it on the mouse here, it's gonna be less detail, it's gonna be weird. But if you insist on that and you have more exposure, it's gonna get more and more detail, more and more data, and then your final mesh is gonna be it's gonna be more detail, yeah. So yes, it's dependent on the exposure for sure. So the other, can I scan the inside of a car and then cut and program animation out of the mesh? Yes, you can. Maybe you need to make red topology on the mesh depending on how it gets, because it's actually scanning. So maybe the mesh is not going to be like good for animating. The edge loops are not going to be like perfect. So maybe if you have like complex animations, they might deform the mesh. So you need to retop to use red topology on that. But that's possible. That's something that people have been using the LiDAR for.
Yeah, good to know for that one. Then we've got here from H. Nguyen asking, can you test run LiDAR sessions from the Unity editor instead of using Mars or making a build through Xcode?
No, not yet. So actually you need to build. This is something that I think they are bringing to the companion app at some point. So you can like have the app on the device and then test on the editor. But at this point, it's not possible. You actually need to build in order to test.
Mm-hmm. And that was the companion app. Is that right?
Yeah. But that it doesn't support it yet.
Okay. Perfect. One here from Jason. Jason's asking, what is the best scanning app on iPhone for scanning areas?
I didn't test a lot of them. I didn't test many, but the ones I liked are the ones here that I downloaded. So this 3D scanner app, I think it's pretty good. Like I scanned the small objects, but I actually scanned like an entire room. And it does work. Like I wasn't that patient to make that work, but you can see here that I have it quite of working. So with a little bit of patience, you can get like entire big areas or small objects working. So I tested this one, and I quite like it. 3D scanner app.
3D scanner app.
Yeah. I think it's free. Yeah, it's probably free. So I didn't test many, but this is the one that I test the most. 3D scanner app.
3D scanner app. Hope you got that one, Jason. But do let us know if you come across anything cool. I'm sure Jerry would love to test that out as well. Perfect. One here from Daryl. Daryl, great seeing you again. How effective is the iPhone 12 Pro in scanning space and objects for 3D use in Unity? So what would be the next available option of current LiDAR devices to consider to increase quality to capture a 3D environment for 6DoF?
Well, I didn't test like that much, but from what I had the chance to test, I think it's pretty effective. Like I could get big objects, small objects, textured objects. I exported them into Unity and I could use them. So I think it's really good. In terms of next available options, I don't know. What I think is gonna happen is more manufacturers are gonna start including LiDAR sensors to their phones as well. But how to improve the technology, I don't know. I'm not like an engineer and expert in this. I don't know what can be done to improve it, but one thing that I think is going to happen as next steps is basically more devices coming with those types of sensors.
Mm-hmm. Perfect. So let's finish up this one. Make sure I didn't miss any other ones. I did. So one here from Sophia. Sophia's asking, do you have art-related VR implementation that are worth checking by chance? If not, Sophia, I do know some people I can reach out to and send those to you.
Yeah, I think I have some people that could have better suggestions on that. So I'm not the best person. I am not. Well, I don't. On the top of my head, I can't come up with anything, but I can reach out to a couple of colleagues that are like artists and everything and see what they suggest and get back to you.
Perfect. Yeah, I'll do the same for you there as well, Sophia. Not a problem at all. One here from Berenice. Berenice is asking, does anyone know how to split the mesh created by LiDAR into multiple meshes depending on the classification? For example, walls, floors, tables, chairs, windows. She wants to get a separate mesh of all vertices that are classified as a wall.
Yeah, that's a really good question. We didn't go over mesh classification in this workshop because it's a little bit more advanced. But ARKit and AR Foundation, they using the mesh system, they have a mechanism for classifying mesh. So I can ask, for example, is this mesh something that I know? Is it a wall, floor, table, chair, window? Those are the things that actually it's not necessarily chair. They call that seat. So it's anything that you can sit. But you can classify the mesh. So wow, I only want essentially this thing if it's a floor or if it's a wall. If you want to separate the mesh, you need to have multiple mesh filters. So you need to create one mesh filter for each one of the classifiers and assign that to the mesh filter. In the Unity AR Foundation examples, which is a Git repo that Unity made for demonstrating how AR Foundation works, they have one scene called mesh classification, and there is a script there that does exactly it. So you can download that project, AR Foundation samples, go to the mesh classification scene and see how they do that. But basically it's very simple. They create one mesh filter for each one of the types that can be classified into.
Mm-hmm. Perfect. Great question, Bernice. Great question. One other one here from Jason, and we may have touched up on it briefly. Again, what's the best LiDAR mobile app for scanning large space?
Yeah, I would say from the ones I know, I would still say this one, how it's called again? 3D scanner app. Like I scanned big areas with it and it worked just fine. I didn't test that outdoors, so I'm not sure if the performance is good or not outdoors, but indoors it works quite well. I'm pretty sure there are better ones in there. I just didn't explore all of them, but among the ones I tested, this one was the best.
Mm-hmm. Perfect. 3D scanner app, right?
3D scanner app, yeah.
Got it. Perfect. We've got one from Kirsten. Kirsten, great seeing you here as well. Does LiDAR-enabled device matter? Can an AR project made in Unity export to a Raspberry Pi with a LiDAR sensor?
That's a really good question. And the answer is potentially yes, but not easy. The thing is, I showed how the XR stack works, right? So we have the subsystems, and they communicate with the plugins, which are native implementations. So the way it works today is, well, I'm using mesh. So it's just going to go to ARKit and say, give me the mesh. If it's in a HoloLens, it's going to go to the XR universal platform and say, give me the mesh. If you want to make that work with a Raspberry Pi with a LiDAR sensor, you need to write the native implementation, which is going to be the XR plugin, and plug that into the XR plugin management in Unity. So you need to make the communication between your hardware and Unity. So it's possible, but it's not there out of the box.
Mm-hmm.
Maybe someone did that. So if you Google on GitHub, probably someone developed that, I would say. But yeah, it's possible. It's just not there out of the box.
Perfect. And if you do have any more questions there, Kirsten, feel free to reach out to us on Slack. I think you should be there. One here, let me just make sure I didn't miss anything. Scrolling up. Nope. Perfect. Going down, Dominica's asking, I want to create application or a game for AR. I want to use LiDAR function for this. Can you help me? How can I use LiDAR? So I thought to use Vuforia and AR Foundation, but I want to use LiDAR function for better games.
Mm-hmm. Yeah, you need to choose either one. Like you cannot use Vue4 and AR Foundation in the same project. Well, actually you can, but that's not recommended. And the thing is, I don't think Vue4 supports Lidar right now. I might be wrong. It's a while since the last time that I played with Vue4, but I do know that they have like area targets, so maybe that works with the Lidar. But basically, you can go over what we did here today, so you can understand like when you have more time to explore the project. But to use the AR Foundation and use the Lidar, you just need to do what we did here today. Add the AR session origin, the mesh manager, and then you have access to the meshes and you can do whatever you want for your project. So that's what I recommend. Just try to rebuild what we did here and expand your game from there. I'm not 100% about Vuforia, so I would need to check the documentation to see if they implement that. It's been a while the last time I tested Vuforia, but maybe they have it. So it's gonna be like the same. You just import Vuforia in there, go to their documentation, see how it works, and then you bring the behavior there.
Perfect. And do let us know on Slack, Dominica, if there's any more information that you need about this. But looks like we've got a question here from Jenny that's been upvoted here recently. Jenny, great seeing you. Have you ever used Microsoft's Azure Connect? If yes, what do you think of it?
Well, I did use it a couple of years ago, and I like it. Like, it's a little bit different from what the Lidar does. So actually, the Connect, what it does is basically motion capture, and you can do that with the iPhone and ARKit 3 as well. With the, ARKit 3, it does have like human body detection. And I think it's very similar. Like I do like the Azure Connect. I don't think it's better than the iPhone, but it's not worse as well. So it's a matter of how are you planning to deploy your application. So I don't know. I haven't seen many people using Azure Connect anymore, just because well, the infrastructure is a little bit more complex, and people have been preferring to use AR Foundation if it's for iOS. The thing with Azure Connect is that you can use that in different platforms. So maybe that's an option as well. Yeah, it's a good option. It's a good option as well.
Perfect. Perfect. Then one here from Sophia as well recently. Can we scan outside places with LiDAR like park, airport, or I assume, how could this be possibly achieved? So I myself want to say yes. You can use LiDAR for all types of scanning. How effective would it be with an iPhone itself? Not too sure, but feel free to add more to that, Jerry.
Now, I completely agree with you. Like, it's possible. That was why the LiDAR sensor was invented for. It's basically like georeferencing. So they just go with an airplane and scan the entire forest or something like that. So yeah, it's possible. I haven't tested that in the iPhone yet. I would say it works, because there's no reason why it wouldn't work, because basically it's laser. So the laser is super focused. It's not influenced by the light in the environment. It's like it's not divergent. So the laser is super concise. So I think it's gonna work. It's just basically like the light goes and go back, and I can see how long it takes. I think it's gonna work just fine in outdoor places as well. I just didn't test that myself.
Right. Yeah. And I have seen myself, they actually used the LiDAR on their iPhone to scan their car outside in the snow. And the 3D model that was presented after was almost on point. Like the car, the snow on top of it, really great scan of it. So we have about 7 minutes here before we do wrap up. And I'll try and get through as many questions as I can. We have one here from Gabriel about an hour or so ago, so hope you're still tuned in here. But automated methods for cleaning and preparing meshes, crucial for scaling and mobile browser lightweight applications. Any insight there, Jerry?
Yeah, I'm not I'm not a 3D artist, and I'm not the best person to answer that. But I know that every modeling software out there, they come with something like that. Like Blender, for example, there's an option to automatically prepare the mesh, but I don't know how effective they are, and I don't know how it works. Being really honest, like I'm not a 3D artist, so that's not what I do most of the times. But as you said, this is basically crucial, as you said, because the scanned mesh is not going to be super accurate. Maybe it's going to be dirty at some points. but I'm not aware like what is the best application to automatically prepare that. What I think people do most of the times is retopology, so they just try to clean that manually as much as they can. But I might be wrong. Again, I'm not a 3D artist, so maybe someone in the audience can have a better experience with that.
Perfect, perfect. Berenice again with a question here. Concerning the distance measured by LiDAR, what is the maximum distance that works? 10 meters up to 30 meters? Is there a parameter which they could, adjust concerning the distance?
Yeah, I think that it is 5. If I'm not mistaken, it's 5 meters in the iPhone. I've seen something like that, but yeah, I'm pretty sure it's 5 meters. But let me see if I can see the documentation here.
Yeah, as you're looking for that, Jerry, I'm not too sure about the iPhone. I assume it's fairly small,
Yeah,
but
it's 5 meters.
Five
It's 5
meters.
meters.
Yeah, depending on the LiDAR scanner itself, they do have them in planes for these geography scans, and a plane from the terrain itself is quite high. So it really depends on the scanner itself, right?
Yes, exactly. Yeah, exactly. But in the iPhone specifically, that is 5 meters. But
Perfect, perfect. And here's one from Dev that I'll answer quickly. Dev is asking, can you leave the room open for 10 minutes after to catch up on updated comments post-workshop? Yes, if you stick around, this will just replay itself. So you'll still be able to check the comments, check out this recording. We will send you the recording afterwards, but feel free to stick around. You'll be able to see all the questions, and it'll just replay the recording itself there. One from Daniel here. Daniel's asking, from your perspective, is AR getting to the point where it might be applicable to precision measuring, given the right controlled conditions? By measuring, I mean, for instance, determining if a mechanical tool is making the correct motions.
Yes, I think so. That's already possible. Like with the LiDAR sensor, it's quite accurate already if it's in a smaller range. So I think so. I think there are a couple of more adjustments that they need to do in there to make it even more precise. But it's the same technology that autonomous cars use, for example. They use LiDARs to see that correction. So yeah, I would definitely think so. Because using...
Opa. Oh, you're back. So you're good. You're good. You're back, Jerry. He was back, and now he's gone. But we'll be sure to get that question to you there as soon as possible here. Let's see if there's anything else. We do have 3-4 minutes. Berenice is asking, do you maintain a Slack group or similar for your attendees? Yes, we do have a Slack group available for those who aren't in our courses and programs. It does include all of our alumni and students as well in these private groups. But essentially, we have a Slack community, Slack group. We are launching another community, xrcommunity.co. Feel free to check those out, and hope to see you there, Berenice, whether it's in Slack or the community that we're launching here. But let's see, Jerry, you cut out for a second there, and then you got back. Not too sure if you finished answering that question or not.
Well, I don't know yeah, probably. The answer is yes.
Okay, perfect. So a couple of more minutes here, and I'm just going to do upvoted and most recent, those of you who are still sticking around. So we've got Berenice, this was an hour ago. Husnain is asking, what is the best practice to start with LiDAR?
What is the best practice to start with LiDAR? Well, I think first you need to define what you want to build with that. Like, where do you need this precision for? What is your application? So I think the best practice for starting with LiDAR is the same best practice for starting with anything else. Like, you need to define where you want to go with it and design the application for the experience, and then you go from there. You need to have an iPhone 12 in there and Mac as well, so you can test your things. But I think starting from the beginning and building on top of that, like prototyping your experience, and then going from there. Yeah, iPad Pro is fine. Any device that supports this thing.
Perfect. Now, I feel like I missed another upvoted one, but we're running short on time here. Another 2 minutes or so. Ali here is asking, I downloaded a LiDAR scan E57. how do I import this into Unity, or what needs to be done to convert before import?
It's going to depend on the app that you have in there. The one that I have here, the one that I mentioned a couple of times, how it's called again, the 3D scanner app, it has an option to export into different formats. So what I would recommend is check if your LiDAR scan exports to FBX format. It's the best one to get into Unity. But if it exports as an object, that's going to work as well. So there are a couple of formats that are supported in Unity. You just need to export to one of those, FBX being the best one.
Perfect. So let's do 2 more questions here. One is from Joseph. I'll answer quickly. The code by Jerry, we will send it all to you all, so no worries. You will have that, Joseph. Not a problem. Another question from Joseph. How does the concurrent queue size affect the meshing?
Yeah. So that's basically the parameter that is going to determine how many meshes are going to be processed at the same time. So it's basically like how many jobs I want to have processing different meshes in parallel. So you need to adjust that based on the performance of your app. I think by default, what is the value by default? I think it's 4, if I'm not mistaken. Let me see here. It's 4. So it processes, it tries to process at least 4 at the same time. But that's what it does. It's basically how many meshes are being processed at the same time.
Perfect. Then let's do one more. We'll wrap it up here with this last one. Let's see what we've got here. Let's do this one because it's a little more technical one, but a short one. Is mesh considered anything that has dimensions for these that might not be as familiar here?
Yeah, I would. The mesh is basically one triangle or a couple of triangles. So mesh is basically the topography or the geometry of something. So the minimum mesh that you can have is like 3 points, triangle, and you can build a mesh from multiple triangles. So basically the mesh is a representation of a geometry in terms of vertices and triangles. That's what a mesh is. So it's not everything that has a dimension, because a point has 1 dimension and a line has 2 dimensions, but they are not meshes. So you need to have at least 3 dimensions to have a mesh.
Perfect. And you know what? I don't want to leave Zach hanging here because he did add 1 question. So Zach, my man, I'll pull this up one and then we'll have to wrap it up there. Zach's asking, do the LiDAR functions work with the AR Foundation Editor remote plugin? I've meant to download this plugin for a while since I know it lets you quickly test from PC to iOS.
Yeah, I really like this plugin. Like I use it a lot while I am developing for AR Foundation, but I didn't test that really LiDAR yet. So I would say yes, probably, but I'm not 100% sure because I didn't test that myself. But it's quite easy to find now. If you go to the asset store, this plugin says here what it supports. So yeah, it does. It says here meshing. All right, yeah, it does. It does support it.
Perfect. Awesome. Great. So we will have to wrap up there, Jerry. I know you've got a crazy schedule still for the rest of the day here, but all of you still tuned in, thank you so much for joining us on another Circuit Stream workshop and webinar. Feel free to check out our XR happy hours this Friday with Nikisa and any of our future workshops and webinars. We host them weekly, so would love to have you there. And again, Jerry, thank you so much for your time today. Really, really appreciated everything you did there.
Thanks everyone for joining, and I'm sorry for the internet connection issues, and I hope to see you guys again in the future opportunity.
Hey, the show must go on, right, Jerry? But thank you again for your time. Thank you all for joining us. As always, we're here to help answer any questions you may have. And I wish you all a wonderful day, a great evening, night, maybe even morning, depending on where you are. And hope to see you all soon. Have a wonderful day, night, and we'll catch you on the next one. Take care.